In this video, we are going to demonstrate an alternative, or even you might want to think of it as a shortcut to the longer kind of calculation we did on the Pearson product moment correlation, where we had to calculate both the covariance piece that was in this numerator and this cross product piece down here in the denominator that was a cross product of the standard deviation of variable x and the standard deviation of variable y. And here is the way that this would work, and very similar to when we were doing skewness and kurtosis, it's oftentimes easier to work in z-scores, and so the alternative R formula, so an alternative formula for R looks like this. R equals the sum of the z x sub I scores multiplied by the, that's a little bit ugly there, see, multiplied by the z y sub I scores divided by n minus 1. So we have 10 total paired observations down here in the denominator, so 10 minus 1 would be 9. So we already got that one figured out. It's easy. So all we have to do now is sum the cross products here, essentially kind of taking this z of every x sub I score multiplied by the z of every y sub I score. That is the essential nature of this. So to do this, we have to get a z-score for every one of the x sub I raw scores and a z-score for every one of the y sub I scores. Let's review our formula for z. So to get any kind of generic z for every ith score is going to be x sub I minus x bar divided by the standard deviation for x. And if we're going to get a z for any of the y i's, it would just be y sub I minus y bar divided by the standard deviation of the y variable. And so quickly, I mean, we don't have to do all these, but this would be, what is x minus x bar? Well, it's this column A up here that's denoted by red, right here. And so you're going to take, 1 divided by 2.71. This would give you 0.37 as a z-score. And if you did 2 divided by 2.71, you would get 0.74. And then another 2 divided by 2.71 would give you 0.74 again. And just take these out and just keep doing the z-score formula. This is again 0.37, negative, these aren't lining up very well for us here, but negative 1.11, negative 1.85, 0, 1.11, negative 1.11, and 0.74. Let's do the same thing over here for the y's. So this 0 right here from column B, which is our y minus y bar from down here in the numerator, divided by the standard deviation, which is 1.83, is 0 divided by 1.83 equals 0. 1 divided by 1.83 is 0.55. Keep going, negative 0.55, 1.64, 0, negative 1.64, negative 0.55, negative 1.09, positive 1.09, and 0.55. So all we need now to fulfill the numerator over here from our alternative formula is a cross product. And so if I just kind of segregate this out right here and segregate this piece out to make a column, and this column would become the zxi multiplied by the z yi. Then you're going to take the z-score for case 1, which is 0.37, which I will, let's do this in red, 0.37, multiplied by 0 here gives you 0. Let's do the next one in the pink here. You get 0.74 multiplied by 0.55, which gives me 2. We'll do one more here. 0.74 negative 0.55 gives me negative 2. And I'll do the rest in yellow. I think you get the picture now. We get a 3. We get, oh wait, whoa, 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 whoa. Doing the wrong part from my notes here. The first one was 0. Let me go back to the magenta. 1 here multiplied by 0 here is 0. I pay closer attention here. We go back to my green here. So 2 okay, let's try this one more time. Okay, we go back to red. The cross product, lost my concentration here. Cross product of the z-score for variable x and the z-score for variable y. You're going to take 0.37 multiplied by the z-score over here, which was 0 for the same paired observation. 0.37 multiplied by 0 is 0. 0.74 multiplied by 0.55 was not 2, like I just said. It's 0.41. And 0.74 here by this negative 0.55 was obviously then negative 0.41. Let's do one more because I feel like I want to be clear here after I messed up. 0.37 multiplied by 1.64 is going to give me 0.61. Okay, and my next one is going to be 0 because I'm multiplying by 0 here. Even though I'm multiplying it by this number here, it's still going to give me a 0. And now I'll do the rest of these out. So negative 1.85 multiplied by negative 1.64 is 3.03. Then we're going to get a 0 here. And then we're going to get negative 1.21. And we'll get another negative 1.21. And then a positive 0.41. And then what we want to do is we want to sum this because this is what it's calling for up here again in our numerator of the alternative formula is to sum the cross products of the z-scores. So if we sum this, we will get positive 1.63. We now have everything we need to know to plug and chug the numbers here. So the numerator here is going to be positive 1.63. We're going to divide by 9, and I'm going to double check the math on that on the calculator quickly here. But 1.63 divided by 9 gives us our 0.18 that we were able to. Now we're going to be certainly within rounding error here, but this is our 0.18. Puts us right in line with where our long formula over here that we did by hand gave us. Okay, so this is the alternative equivalent formula or way to calculate Pearson product moment correlation using z-scores. I hope that was clear for you, and I hope you enjoyed the video.